So far in trig, when we learned about trig in grade 10 and when we learned about trig in this course so far, we've learned about what we call the primary trig ratios, which are sine, cosine, and tan. We also have three other trig ratios which represent these primary trig ratios reciprocals. So these trig ratios are called cosecant, secant, and cotangent. And similar to how like we have this is sine and tangent and cosine. Similar to how we have like short forms when we actually use them as like functions in our calculator. Cosecant, secant, and cotangent also have short forms as well. So their short forms are CSC for cosecant. And cosecant is actually going to be equal just to the reciprocal of sine. So if sine is equal to, maybe I'll do this one in red. If sine is equal to opposite over hypotenuse, cosecant is equal to hypotenuse over opposite. And if we think about our x, y, and r as well, like we've been working with, if sine is y over r, then cosecant must be r over y. And the reciprocal of cosine is secant. It's abbreviated SEC. And if cosine is equal to adjacent over hypotenuse, secant will be equal to the reciprocal, which is hypotenuse over adjacent. And if we think about it in terms of x, y, and r, cosine we said was equal to x over r, so secant will be equal to r over x. And then lastly, cotangent is the reciprocal of tangent. We abbreviate this COT. And because tan is opposite over adjacent, cotangent will be adjacent over opposite. And in terms of x, y, and r, tangent is also equal to y over x. So that makes cotangent x over y. Okay, so our first example just asks us to come up with all 6 trig ratios, the exact value of all 6 trig ratios for angle A. So if angle A is our reference angle, we're going to label all of these sides accordingly as far as opposite, adjacent, and hypotenuse. So 12 will be opposite, 5 will be the adjacent side, and 13 will be the hypotenuse. So using SOHCAHTOA, we'll just set up the first primary ratios. So sine opposite over hypotenuse will be 12 over 13. Cosine adjacent over hypotenuse will be 5 over 13. And tangent opposite over adjacent will be 12 over 5. Their reciprocal ratios will then just be the reciprocals of these. So the reciprocal of sine is cosecant, and cosecant theta will be equal to simply 13 over 12. Okay, just the flip of whatever sine was. Secant, which is the reciprocal of cosine, will be the reciprocal of 5 over 13, which is 13 over 5. And then same idea with cotangent. Cotangent will be equal to the reciprocal of tangent. So these are our 6 trig ratios. And we can also use these trig ratios in what we've been doing with our primary ratios as well. So like in our special triangles, and we can actually even extend the first part of this lesson into finding angles with reciprocal ratios as well. So firstly, if we're using special triangles, this one can be done by simply just looking at the 30, 60, 90 triangle. So I'm just going to draw that. So side measurements 1, √3, and 2. So if cosecant is the reciprocal of sine, and we're doing the cosecant of 30, I'm looking to use opposite and hypotenuse. But instead of opposite over hypotenuse, we'll do hypotenuse over opposite here. So that will be 2 over 1, which we can simplify to 2. If you want, you can draw this like in the first quadrant, like if you want to draw your quadrant grid or whatever. But since it's between 0 and 90, we can just draw the special triangle and we have enough that we can figure out the ratio from that triangle. Okay, secant of 180. We talked about how we find 180, 90, 270, 0, 360 using the unit circle. So I'm going to use the unit circle here. We reviewed this at the beginning of today as well. If this is the unit circle and I'm trying to find information at 180, I need to know what this point is right here. I also know the radius of the circle is 1. But this point here is, if we go 1 unit over on the x-axis, it's negative 1, 0, where negative 1 is x and 0 is y. So looking up here, we said that secant, being the opposite of cosine, will be r over x. So if I'm doing secant of 180, I'm doing r over x, which in this case is 1 over the x coordinate at 180, which is negative 1. So we'll get negative 1 for the secant of 180. Okay, and then we can also use the cast rule. The general rule for the cast rule in using the reciprocal ratios is that the reciprocal ratios will be positive where their primary trig ratio is positive and negative where their primary trig ratio is negative. So if I take the cotangent of 135 and I want to find the exact value of this, I'll just start by drawing a picture here. We're going to place 135 in our quadrant grid. And 135 is going to fall about halfway between 90 and 180. It's going to fall right about here. And we're going to follow the same sort of steps that we usually follow for questions like this. We're going to find this little reference angle inside here. By doing 180 minus 135. And that will give us 45 for the reference angle. We'll make the special triangle as usual. So that will be 1, 1, and root 2. And we're also going to use the cast rule. So keeping in mind that cotangent is the reciprocal of tangent, cotangent will be negative where tangent is negative and positive where tangent is positive. So if I'm trying to take the cotangent of something in the sine quadrant, what would I expect to get from my answer here?
Negative.
A negative, yep. So I should expect that the cotangent of 135 is actually equal to the negative cotangent of 45 degrees. And because cotangent is the reciprocal of tangent, I'm looking for adjacent over opposite to do cotangent. So in this case, it will be negative 1 over 1, which gives us negative 1. Okay, so basically exact same process as what we were working with before, except you just need to know which reciprocal ratios are the ratios that match up with which primary ratios in order to just make sure that you know what sides are required. But same process as usual for these. Use the same triangles, place the angles the same way, use the cast rule the same way. Any questions so far?
You use 45 there, not like 30 or 60, because like it's 80 minus 35, right?
Yeah, when we do 180 minus 135 here, we get a reference angle of 45. So that tells me what special triangle I'll be using.
Okay, yeah, it's right there, so I didn't see it.
No, that's okay. Okay, so we're going to extend what we learned today into finding our angles using reciprocal ratios. So whenever I do these types of questions, there's really only one extra thing that we have to do, and then we'll follow the same steps as what we did earlier today. So whenever I'm approached with some reciprocal ratio equals some number, I'm going to actually switch that into the into the primary ratio. So if I know that cosecant is the reciprocal of sine, this is technically -2/1. Okay, because we know that any regular number has a denominator of 1. So that means that sine theta must be equal to -1/2 when I do the reciprocal of this. Now I'm going to solve this the exact same way that I always solve. I'm going to draw my quadrant grid. And I'm going to place my angles for theta in the quadrants where sine gives out a negative answer. And we're going to do that by using the cast rule. So where might my angles fall, or what quadrants will my angles fall if sine is -1/2?
Quadrants 3 and 4.
Correct. The tan and cosine quadrants. So here I'll have some theta, and here I'll have another theta. So we'll call this theta 1 and theta 2. And we will start by doing sine inverse of -1/2 to get theta by itself. And you should get -30 here. Now, this answer is a bit of a problem because this question asks me to determine two angles between 0 and 360. So if my theta has to be between 0 and 360, this falls outside of that range. That's less than 0. So how do I make a negative angle positive?
Can't you add 360?
Yes. So in other words, we're just finding its positive coterminal version, right? So we're going to add 360 to make the angle positive. And that's going to give us 330. That makes a lot more sense because we're looking for something in between 270 and 360. So we've actually just found theta 2 here. This is 330. So we'll label that theta 2 to match with our drawing. And can somebody tell me what's the reference angle here? What is the measurement of this angle inside here?
$30.
Should be 30 degrees. Okay, we can clearly see that anyways because we rotated -30 degrees. So the angle measurement between 330 and 360 must be 30 degrees. And that's also going to be true on this side over here. So how do we find this full rotation to theta 1?
You do 180 plus 30, which is 210 degrees.
Perfect. Thank you. So that's going to be what we've labeled as theta 1 in our drawing. Awesome. So again, we have to kind of use our common sense for this. If I'm going from 0 to 180 and then past 180 by 30 degrees, then I want to add 30 to 180 to get that 210. And you can check your answer, except we don't have cosecant in our calculators. So you actually have to check it in sine here. So if you do the sine of 330, you should get negative 0.5. And if you do the sine of 210, you should get negative 0.25 again, because that's negative half. Okay, let's try another one. Secant theta equals 5/2. So first things first, we're going to switch this into its primary trig ratio. So if secant equals 5/2, that must mean its primary ratio, which is cosine, equals 2/5. Then we're solving as usual. So we did a bunch of practice with this today. So I'm going to ask you guys to try this out on your own. So can you find all possibilities for theta between 0 and 360 where cosine is equal to 2/5? So let's try that. Okay, Ben. What did you do here?
So I made the drawing, like the Cartesian plane, and I made the two lines in quadrant 1 and 4 because cos is positive, and those are the only two where cos could be positive. And then I did inverse cos. Oh, sorry.
So, sorry, yeah, just let me get caught up here with you. Okay, so Ben placed his angles in quadrants 1 and 4 in the A and C quadrants because we're looking for where cosine is going to give us out a positive answer. So cosine will give positive answers in all and cosine. Okay, continue, Ben.
And then I did cos inverse of 2/5 to get the first angle, which was like the one that was pointing upwards, I said.
Mhm.
And that was 66.24. then-
I thought I got 66.4. Let me just double check. 66.42. So should be but 66.4.
Okay, then I subtracted it from 360 to find beta 2, so 360, which was 293.6. And that's it.
Perfect. Thank you. Oops. Okay, any questions on this one?
Yeah, how do you know you're subtracting from 360?
Well, here's the rotation that I need. I need this,
Oh, yeah, okay.
and I know this piece.
Okay, I got it.
How do we know the top one is number 1 and the bottom one's number 2?
You can call the top one number 2 and the bottom one number 1. Doesn't really matter. We're just saying one of the thetas is 66.4 and the other one is 293.6.
So is one of them like the angle and the other one's the rotation?
What do you mean?
Like theta 1, we're finding the angle at 66.4
Yeah.
degrees, and then the other one we're finding like the rotation.
So this is a rotation as well, right? It just rotates to here.
Okay.
So they're both rotations, technically. They're both angles. If that makes sense.
Yeah.
Okay, let's try one more. I'll give you guys a head start on this one. See if you can find the theta between, or both thetas between 0 and 360 that will give us a cotangent of 5/16. So overall, same process. We are going to just do this extra first little step. Switch your primary ratio or switch your secondary ratio into your primary ratio. Sometimes we call the reciprocal ratios the secondary ratios. So switch the reciprocal into the primary ratio. Decide where your angle gets placed based on whether you have tan, cosine, or sine, and whether your answer is positive or negative. And then you're going to use the inverse function to find your first angle. And then you've got to sort of use your common sense to find that extra angle. The picture will help because if you know that it should fall between 180 and 270 and you get something like 130, that won't make sense, right? So just sort of use your knowledge there. In general, this is going to be 180 minus the reference angle. This quadrant will be 180 plus the reference angle. This quadrant will be 360 minus the reference angle, if that's helpful for you. Okay, and then can somebody tell me how we can check our final answer here?
You have to do a tan with like 72.6 and 252.6.
Right, and we check to see that it gives us out the decimal value of 16/5. Perfect. Okay. So we are going to do a couple more practice questions to close off today. You guys have about a half an hour. So your questions, let me just show you what's assigned here.